Welcome to TalkTensors, where we try to make sense of sometimes pretty dense machine learning papers.
Yeah, boil them down to what really matters.
Exactly. And today we've got a really interesting one. It digs into a question that feels, well, increasingly important. When we build these AI agents, do we always need the most advanced, the most powerful reasoning models for the job?
That's the core of it. This paper examines how reasoning actually functions within large language model agents.
Yeah.
And what I found interesting is it doesn't just assume more reasoning is always better.
Right.
It actually tries to pinpoint, when is that deep thinking absolutely essential and maybe when is it just overkill, adding complexity we don't strictly need.
So for everyone listening, this deep dive is basically your shortcut to understanding this study. We're going to explore their framework, LARMA, they call it, which they use to systematically test reasoning in different agent setups. The goal here is to figure out if these newer superpowered reasoning models, LRMs, large reasoning models, are always the secret sauce for making AI agents work well.
And it's super relevant because LLM agents are everywhere now, or at least the ambition is for them to be, handling complex tasks, making decisions autonomously. It's a huge step up from older AI, the rule-based stuff, or basic reinforcement learning.
Absolutely. We see them proposed for everything: customer service, complex data analysis, even helping with research. They're great at understanding context, generating responses, using tools.
Yeah, using external tools is a big one, integrating knowledge. But, like this paper points out, the current way we build these agents, it's not perfect. There are challenges.
Okay, yeah, let's touch on those. The paper mentions things like, well, the computational cost, right? These things are resource hungry.
Definitely. And efficiency, how fast they work, especially when time matters.
And the big one, hallucination. The risk that the agent just makes stuff up when it doesn't know.
Exactly. Which leads us to this really critical question, especially now with the rise of these dedicated large reasoning models, LRMs, coming out of places like OpenAI, DeepSeek, and models built specifically for complex multi-step thinking.
So the question becomes,
are the standard ways we've been building LLM agents still the best approach? Or with these powerful LRMs available, do we need to rethink things? Are we sometimes over-engineering?
Right. So to tackle this, the researchers developed LARMA. It's this framework designed to really dissect reasoning's role. And it does this in 3 main phases.
The first phase is task segmentation for agent capabilities. Basically, they break down tasks based on how much reasoning they seem to need.
Like what kind of reasoning?
They look at things like using external tools, designing plans to reach a goal, and just general problem solving.
Okay, so for tool usage, for example.
They get quite granular. There's tool awareness. Does a model even know it needs a tool? Then tool selection, can it pick the right tool? And tool capability, can it use the tool correctly, give it the right inputs?
Makes sense. Break it down.
Precisely. Then the second phase is selection for generic agent paradigms. Here they look at 2 common ways to structure agents: react and reflection.
Okay, react. I've heard of that one.
Yeah, react is very interactive. The agent reasons, then acts, then observes the result, then reasons again based on that feedback. It's iterative, great for when the agent doesn't have all the info up front, like exploring an unknown environment, what the paper calls a POMDP situation.
Partially observable Markov decision process. Got it. So learning as you go. What about reflection?
Reflection is more introspective. The agent tries something, gets feedback, then literally writes down a critique of its own performance, reflects on it, and uses that reflection to improve the next try.
Oh, okay. So less immediate back and forth, more learning from past mistakes through self-analysis.
Exactly. It demands self-evaluation, that reflective reasoning capability. So these 2, react and reflection, represent these sort of interactive versus reflective modes.
Okay, tasks segmented, paradigms selected.
Right.
What's the third phase?
Phase 3 is performance assessment with different LLMs and LRMs. This is the testing phase. They take a bunch of models, standard LLMs and these specialized LRMs, and run them through the different tasks using both react and reflection.
And they measure
What?
just accuracy.
More than that. Accuracy, yes, task pass rate, but also efficiency, time taken, steps needed, cost, resource usage. And they even look inside the reasoning process.
Cool.
By analyzing the chain of thought, the quality of the thoughts generated, even how long those thoughts are.
So it's a really comprehensive look, not just if it worked, but how it worked and how efficiently.
Exactly. The goal is to get practical insights. When is advanced reasoning really paying off? Can we guide deployment better? Maybe even design new hybrid agent architectures?
That makes a lot of sense. Okay, so before we dive into the specific findings, maybe let's just quickly trace the path that led here. What's the context? How did we get to the point where we're asking these questions about reasoning and agents?
Good idea. Well, AI agents have come a long way, right? We started with systems that just followed hard-coded rules.
If this, then that.
Pretty much. Then came reinforcement learning agents, learning by trial and error, maximizing rewards. But the real game changer was the arrival of large language models, GPT-3, GPT-4, LLAMA.
These models that suddenly understood and generated language incredibly well.
Right. And that breakthrough in natural language processing was key. Suddenly, agents could understand complex instructions, generate nuanced responses, interact with messy, real-world systems.
And use tools, integrate knowledge from outside sources.
Exactly. But as they got more powerful, those concerns we mentioned, compute cost, speed, the potential for making stuff up, hallucination, they didn't go away. In fact, they became maybe even more prominent.
Like the bigger the engine, the more fuel it needs, and the more careful you have to be driving it.
That's a good analogy. And then more recently, we saw the emergence of these large reasoning models, the LRMs, models explicitly designed by places like OpenAI, DeepSeek, Qwen, to handle complex multi-step reasoning problems.
So the stage was set. We have these general-purpose, powerful LLMs, and now these specialized reasoning powerhouses, the LRMs.
And the question this paper tackles head-on is, are those advanced reasoning skills in LRMs always beneficial when we plug them into an agent framework? Or does the context, the task, the framework itself change the equation?
Is the extra reasoning horsepower always worth the cost?
That's pretty much it. That's the core tension this historical path leads us to investigate.
Okay, great context. So let's get back into the LARMA framework itself. Phase 1, task segmentation. We covered tool usage. What were the other main areas they looked at?
Right, so tool usage was one big bucket. The second was plan design. This is about the agent figuring out a sequence of steps to achieve something complex. The paper gets into the specifics of how they tested this later with specific data sets and experiments.
So strategic thinking, basically, laying out a path.
Exactly. And the third domain was problem solving, kind of a broader category for tasks needing logical deduction, inference, maybe pulling together different bits of knowledge.
Okay, so tool usage, plan design, problem solving, these give them a structured way to probe different reasoning demands.
Then phase 2, they picked those two agent paradigms, react and reflection. Why those two again?
Well, react is super common, right? It mimics how we might tackle a problem in the real world. Try something, see what happens, adjust. That interleaving of reasoning and action, getting feedback, it's crucial when you don't know everything up front. That POMDP idea again.
Navigating with partial information makes sense for interaction.
And reflection.
Reflection represents that other key aspect of intelligence learning from experience, self-correction. Having the agent analyze its own failures, write critiques, and use that to improve, that really tests its reflective reasoning capacity.
So you've got the interactive approach and the reflective approach, two distinct ways an agent can operate and learn.
Yeah. And by testing models across these different tasks, using these different paradigms in phase 3, they can start to see where different models shine and how the structure of the agent matters.
Right. And the third phase, the performance assessment, they used a really solid lineup of models. For the standard LLMs, they had heavy hitters like LMA 3.170B, GPT-4o, Claude 3.5 Sonnet, kind of the state-of-the-art generalists.
Exactly. And then they brought in the LRMs, the specialists, models like DeepSeek R1, Claude 3.7 Sonnet, Gemini 2.0 Flash, a couple of others too, QWQ 32B Preview, GLM0.
So a direct comparison between the generalists and the reasoning specialists.
Yep, and evaluated using that whole suite of metrics we talked about, accuracy, efficiency, cost, and digging into the reasoning quality itself.
Okay, framework understood, context set. Now for the really interesting part, what did they actually find? What were the key takeaways from all these experiments?
Okay, so one of the clearest findings, looking at the results tables, was that the reflection paradigm generally did better than react.
Better across the board. For both types of models.
Pretty much, yeah, for both the standard LLMs and the LRMs. But interestingly, the improvement from using reflection was often bigger for the standard LLMs.
Huh. Why might that be?
The thinking is that reflection's whole iterative process, try, reflect, critique, try again, really plays to the strengths of LLMs. It gives them multiple shots to refine their output based on structured feedback.
Like a built-in learning loop that helps them get closer to the right answer over time.
Okay.
But you said the benefit was less pronounced for the LRMs.
That's right. which suggests there might be some overlap. You know, the advanced reasoning capabilities already baked into the LRMs might be doing some of the work that the explicit reflection step does in the reflection framework.
So the LRMs are maybe already doing some level of internal reflection or correction, so the external loop adds less value?
That seems plausible, yeah.
Wait,
It's like they have less room to improve from that specific mechanism because they start from a stronger reasoning baseline.
interesting distinction. Did they look deeper into how reflection worked over those cycles?
They did. They tracked performance across reflection iterations. And, as you might expect, the top LRMs, DeepSeek R1, Gemini 2.0 at Chash, Claude 3.7, generally hit higher performance ceilings than the LLMs and weaker LRMs, especially on the harder tasks.
Which supports the idea that for complex reasoning, the specialized models do have an edge.
Definitely. But how they got there was different. The LRMs often got close to their best performance really quickly, maybe just 1 or 2 reflection cycles.
While the LLMs?
The LLMs often needed more turns, sometimes 4 or 5 cycles, to reach their peak. It suggests different optimization paths. LRMs might find the good solution faster, while LLMs benefit more from that extended refinement.
And did the type of task matter here? Did LRMs always win?
No, not always. Performance definitely varied by dataset. LRMs really excelled on structured tasks, like the PlanBench dataset, which involves logical planning.
Okay.
But LLMs, with their strong language skills, sometimes did better on less structured tasks, like the Webshop dataset, which involves understanding product descriptions and navigating a simulated online store.
Right. Playing to their strengths. LLMs for language nuance, LRMs for structured logic. What about the React paradigm? They looked at that think step, didn't they? The reasoning before acting.
Yeah, they compared the standard React act think with a version where they just removed the thinking step, act only. In complex, real-world type tasks, needing planning like navigating a simulated house, taking out the think step, really hurt the LLM's performance. Badly.
Okay.
But the LRMs, they were much less affected. Sometimes their performance even got slightly better without the explicit think step.
Whoa. So LLMs seem to really rely on that explicit planning phase for complex navigation, but LRMs might be able to bake that planning into their action selection more implicitly.
That seems to be the implication, yeah. But then, for the more structured web shopping tasks.
Let me guess. Removing the think step was better there.
You got it. For both LLMs and LRMs, the act-only mode improved performance in web shopping. The idea is that for simpler execution-focused tasks, the explicit thinking just adds overhead without much benefit. Faster to just act.
So sometimes thinking less is actually more efficient. Fascinating. Okay, what about zero-shot versus few-shot performance? Remind us what that means quickly.
Zero shot. The model gets the task cold. No examples. Few shot. He gets a few examples in the prompt to show it what to do.
Right, and the difference?
LLMs took a big performance hit on those complex, real-world tasks in the zero-shot setting. They really benefited from seeing examples.
Needed that guidance.
Seems like it. LRMs were generally more robust in zero-shot. They handled it better. But still, their performance usually dropped compared to few-shot.
But wasn't there a twist with the web shopping tasks?
Yeah, this was interesting. For web shopping, some models actually did better in zero-shot.
Better without examples. How?
The hypothesis is that for those structured tasks, the examples might have actually just cluttered the prompt, making it more complex than needed. Removing them let the model focus on the simpler core task.
So the examples were almost like noise in that context.
Wow. Okay, the paper also mentioned dilemmas with LRM, specifically overthinking.
Yeah.
What's that about?
Right. They looked at how much time and sort of computational effort measured in tokens the models spent thinking. They found some LRMs, DeepSeek R1 in particular, had a higher tendency to get stuck in long thinking loops, producing a lot of thought tokens without necessarily improving the outcome.
They called this an overthinking rate. Exactly. And they compared it to, say, Claude 3.7, which might have had long thinking processes overall, but a lower rate of this apparently unproductive overthinking.
So it's a trade-off. You get deep reasoning power, but you risk the model getting lost in thought, spinning its wheels inefficiently.
Precisely. Which leads nicely into another key finding, combining LLMs and LRMs.
Ah, the hybrid approach. How did that work out, especially in reflection?
This was really promising. They tried using an LLM as the actor, doing the task steps, and an LRM as the reflector, doing the heavy lifting during the reflection phase.
Yeah.
That combination often gave the best results, especially for those tricky plan design tasks, like using Claude 3.5 LLM as the actor and DeepSeek R1 or Claude 3.7 LRMs as the reflector worked really well.
So you get the efficiency of the LLM for execution, but the powerful reasoning of the LRM for the strategic reflection and improvement.
That seems to be the winning combo. It leverages the strengths of both. Using an LLM for reflection was okay, competitive sometimes, but generally not as good as an LRM for the really reasoning heavy lifting.
Okay, so this gives pretty clear answers to their research questions then.
Yeah. RQ3 was about optimizing reflection, and the LLM actor plus LRM reflector seems to be the answer there. And RQ4 asked if LRM reasoning is always necessary.
And the answer is, it depends. Crucial for complex reasoning tasks like planning, but less so, maybe even detrimental due to overhead, for simpler execution-focused tasks.
Exactly. It's all about matching the tool to the job. The paper also briefly connects this to other agent frameworks out there. React, AutoGPT, Baby AGI, MetaGPT, noting they all grapple with similar challenges in balancing capability, cost, and control.
So the big picture seems to be, this study gives us valuable data to think more strategically about how we use LLMs and LRMs and agents, and these hybrid models look really interesting.
Definitely. It pushes us beyond just use the biggest model, towards a more nuanced understanding of reasoning, task demands, and agent architecture.
Okay, so that brings us nicely to our novel notions section. Based on everything we've just discussed from the paper, what are some, interesting next steps or new ideas this research sparks for the field?
Well, that whole overthinking finding with LRMs is pretty intriguing. One direction could be developing ways to make the LRM's reasoning depth dynamic.
How do you mean?
Like, could the agent somehow sense the task's complexity or its own confidence level and adjust how deeply it reasons? Maybe develop metrics to detect when it's starting to overthink in real time and have mechanisms to sort of prune those unproductive thought branches.
Give it some metacognition almost. Okay, I'm spinning my wheels here. Let's scale back. I like that. What else?
Given how well the LLM-LRM combo worked in reflection, the reflective paradigm, maybe we could explore similar synergies within React, the interactive one.
How would that look?
Perhaps you could have an LRM acting as a kind of reasoning supervisor for a faster LLM actor. The LLM handles the quick actions and observations, but the LRM provides higher-level strategic guidance or corrects course periodically within the React loop.
A strategic advisor whispering in the ear of the frontline agent. That's a cool concept, potentially bringing deep reasoning into more dynamic situations. One more.
The fact that performance varied so much, depending on the dataset, LRMs excelling on structured tasks, LLMs on unstructured, points towards adaptive architectures.
Meaning?
Imagine an agent system smart enough to analyze the incoming task and then decide whether to deploy an LLM, an LRM, or maybe a specific hybrid configuration best suited for that particular job.
So a meta agent that routes tasks to the right kind of specialist brain.
Something like that, yeah. It would require good task classification up front and a solid way to benchmark model capabilities for different task types.
These are all fascinating directions. It really shows how this paper opens up more questions, pushing towards more sophisticated and adaptable agent designs.
Absolutely. It's clear that just making models bigger or better at raw reasoning isn't the whole story. How we orchestrate these capabilities is becoming just as important.
Well, hopefully you, our listener, now feel like you've got a solid handle on this research. The key takeaway really seems to be that the need for advanced reasoning in AI agents isn't black and white.
It's nuanced. Depends on the task, depends on the agent's structure. And these hybrid approaches, mixing LLM efficiency with LRM reasoning power, they look really promising.
Definitely something to think about if you're working with or thinking about deploying these kinds of agents.
And it leaves us with a bigger thought, doesn't it? As these LRMs get even better, how will this constant interplay between having vast knowledge, like an LLM, and having deep, structured reasoning, like an LRM, how will that ultimately change how we even define intelligence in AI?
That is a deep question to ponder. If you want to get into the nitty-gritty, we definitely recommend checking out the paper itself. And please do join us again next time on TalkTensors for another deep dive into the latest in machine learning.